Okay, hi everyone. Welcome to today's panel discussion on serverless computing. My name is Ben Bussey. I'm the VP of Product Management at Dream Factory. Very excited to have Johnny Kiram, MSV, joining me today. Johnny is an analyst, advisor, and architect at Johnny Kiram and Associates. So we're very excited to discuss serverless computing, explain what it's all about, and try to get everybody up to speed on the technology. So let's kick things off. Johnny, why don't we start with a quick introduction? Can you tell us a little bit about yourself and why you're interested in serverless computing?
Sure. Thanks, Ben. It's my pleasure to be a part of this discussion. So as Ben introduced, my name is Johnny Kiram. I have about 20 years of experience, spent about a decade at Microsoft, followed by a brief stint at Amazon. And I floated a managed services company that got acquired. And for the last 4.5, 5 years, I have been an independent analyst and advisor, working with microservices companies as an advisor, as an extended product manager. And one of my newfound love is serverless computing. So almost in 2014, when Amazon announced Lambda, I realized that's going to be the next big thing because it is the logical extension of platform as a service, backend as a service, and transforming the code and enabling developers to basically run code at a much more fine-grained level. So when I first encountered Lambda, AWS Lambda back in 2014, 2015, I knew it's going to be a big thing. And today, not just Amazon, but almost every platform provider, every cloud provider is talking about serverless computing and function as a service. So I'm looking forward to demystifying some of these concepts along with Ben. And you will actually find this is the logical evolution of cloud that's going to take a completely different direction.
Okay, great, excellent. So speaking of demystifying, the term serverless itself is somewhat confusing, right? So this term is being used, but of course, when you're implementing a serverless application, there are still servers somewhere that are running software. So when you say and talk about serverless, what does serverless kind of mean at a very high level? And then we'll dig into some of the more technical details in a little bit further on in the discussion.
Sure, Ben. So actually the industry is divided in coming to terms with serverless computing. There are two camps which actually believe serverless is the right nomenclature to address this new paradigm. And then there are another set of folks who belong to the other camp that don't believe at all in serverless. So the argument is when your code is ultimately running on a server that has CPU, that has memory, that has hard disk, how can you qualify this to be called as serverless? So keeping that debate aside, serverless doesn't really mean we are going to deal with completely no infrastructure or no ops environment. It's going to be the same. It's not going to be dramatically different in terms of the stack or the infrastructure. But serverless is more to do with the developer experience.
Mm-hmm.
So today, when a developer wants to execute a piece of code, he always thinks about a logical boundary, and this boundary is considered to be a server or a virtual machine, or if not anything, it's at least a PaaS account where he provisions a set of predefined resources, and then the code is going to run on top of it. So the execution is always preceded by provisioning and configuration. So those are two steps that we cannot miss. With serverless, the developer is completely liberated from dealing with provisioning and configuration. So when you remove those two steps and you have the ability of taking your code and executing it without any of the prerequisites, you're essentially dealing with a serverless environment. Of course, there is someone behind the scenes running a fleet of servers, configuring the runtime environment, making sure that your code is securely executed, it is isolated, it is scalable and all of that. But you as a developer is not going to deal with the first two steps of provisioning and configuration. So when you're dealing with an environment that doesn't force you to provision and configure, you're essentially dealing with serverless environment.
Got it. I mean, I think that's really helpful to understand. And in a way, it's abstracting out a lot of what a developer would have to do so that heavier lifting and provisioning and configuration is done by a service provider. And extending that idea a little bit more, we'll talk about the white paper at the end, and where people listening can get that information. Should be really helpful. And in that white paper, you talk about serverless computing, and you talk about this notion of functions as a fundamental deployment unit. And so this model of removing the provisioning and configuration steps and providing, if you will, functions as a service is quite a bit different from infrastructure as a service, what we call IaaS, or platform as a service, PaaS. So can you talk a little bit about, in a concrete way, about what functions as a deployment unit kind of looks like? How does that model work in practice? Maybe you could walk folks through how functions as a service actually works.
Absolutely. So for that, let me step back a little and walk you through the evolution of functions as a service. So we are actually in the fourth wave of computing. And if you're wondering what are the first three, the first wave of computing was triggered by the availability of x86 servers. And this was in the early to mid 90s. Prior to that, computing was always confined to mainframes and mid-ranges and very expensive, very bulky machines. The availability of x86 servers changed the game. So that was the first wave of computing. The second wave of computing was assured by the availability of virtualization, and a lot of credit goes to VMware for democratizing hypervisor virtualization and making it possible to run VMs. So that was the second wave of computing. The third wave of computing is what we are currently experiencing, and this is triggered by Docker. So containerization is the third wave of computing, where we are now dealing with the unit of deployment being a container. The logical extension of containerization is the fourth wave, which is what is serverless computing. So if you look at the evolution, this is one way of looking at the evolution of computing from x86 servers all the way to serverless computing. On the other side, the service delivery models have been evolving. For example, in 2010, Amazon started exposing S3, EC2, and VPC. So basically, that delivered compute, storage, and network as a service, which translated to infrastructure as a service. And on top of that, we have seen services like Heroku, Cloud Foundry, OpenShift, and the platform as a service offerings. The extension of PaaS was available through backend as a service. If you remember PaaS from Facebook, Kingway, and to a large extent even Dream Factory, all of these platforms essentially belong to the BaaS, or backend as a service service delivery model. So those are the various milestones in making infrastructure available to developers on demand as a service. Now, there is a lot of similarity between BaaS and the upcoming serverless computing model. The reason is, if you look at infrastructure as a service, the fundamental unit of deployment is always a VM. So Amazon sells VMs, and you buy VMs on an hourly basis or on a commitment basis. So basically, the pricing, the deployment, the logical architecture, scaling, everything is described in the units of number of VMs. So that is one way of looking at it. The second way of running code is taking a code and running it on PaaS. But PaaS is also not completely friction-free or hands-free. There you need to define code plus configuration. For example, you have to tell what is the available resources that your application needs, and how do you connect the dots. So PaaS reduces the friction by bypassing the provisioning of VMs, but it doesn't free you from configuration. You still need to take configuration along with your code, and that is PaaS. And PaaS also lacks certain features like auto scaling and auto magically managing the underlying resources and some of those capabilities. So it is not completely hands-free. Third one, the third service delivery model is FaaS, where you don't really run code inside it, but you consume a set of APIs. For example, authentication as a service, user management as a service, object storage as a service. So you consume a set of APIs, you assemble those services, and you build an app. But the code has to run somewhere else, either in a FaaS or in IaaS. So that has been the logical evolution. Now, when it comes to serverless, the unit of deployment is going to be fundamentally different. Here, you're not going to deal with VMs. You're not going to deal with code plus configuration. You're not going to consume APIs exposed by the platform. Instead, you take multiple code snippets that are designed to do one task at a time, and you deploy all these code snippets in the serverless environment, and then you connect all of them in a specific sequence that starts to make sense, and it basically becomes a composable application. So you never have to package your app into a VM or into a container, or you're not carrying any configuration. You're writing a function that takes a couple of parameters and returns one parameter, and you create half a dozen of those functions. You deploy all those functions, and then you connect the dots by saying this function is going to be triggered, and the output of this function will be passed to the other one. And when you connect the dots, when you connect all these functions together, what you essentially end up creating is a meaningful, complex application. So that's the reason why in serverless computing, the fundamental unit of deployment is function. And that's one of the reasons why the new service delivery model is dubbed as FaaS, or functions as a service. But I also want to take the opportunity of differentiating between serverless and FaaS because they are almost similar, but there is a subtle difference. Serverless is all about infrastructure abstraction. Mm-hmm. What you run on top of serverless is completely up to you and up to the provider. For example, Google actually calls BigQuery as a serverless data warehouse. It is technically legitimate way of calling it because there is no provisioning, there is no infrastructure resource handling. It is completely abstracted. You bring your data and you start querying it. So it's a serverless environment. So serverless is anything that doesn't have provisioning and configuration to it. Now, functions as a service is a subset of serverless where you bring your code and run it in an environment where there is no provisioning and no configuration and no operations that need to be done. So that is the subtle difference between serverless and functions as a service.
Got it. Okay, yeah, that's really helpful. I think that clears things up quite a bit. Can you talk a little bit about some of the technical benefits of serverless computing, broadly speaking? So, of course, you talked about this idea of reducing friction for developers, eliminating the provisioning and configuration. What are some of the other sort of technical benefits from the point of view of a developer who's tasked with building a modern application, looking at perhaps moving from IaaS or platform as a service and making the leap? What are some of the technical benefits that you see in doing so?
Sure, definitely. So before I touch upon that, I want to call out three clear attributes of serverless platform. So the first one is in serverless computing, we always deal with event-driven computing model, which means we are primarily talking about an environment that's pretty much like Visual Basic of 90s, where you write code that's not going to be running all the time. It is going to be triggered when a certain event takes place. And what event is going to trigger your code is completely dynamic. You can define it at runtime. So the first attribute of serverless computing paradigm is it is event-driven, unlike any other environment where your code is constantly running. That is the first attribute. The second attribute is the pay-per-execution pricing model. Interestingly, when you consume a serverless environment, a serverless platform, you're not going to be charged on an hourly basis or a monthly basis, or there is no commitment that you're going to pay a flat fee. Instead, every time your code is triggered, based on the resources that it's going to consume, the service provider will charge you. For example, if your code is executed for 20 seconds and during those 20 seconds it consumes 0.5 cores and 1 GB of memory, and this code runs for a predefined time window, the charges are going to be based on how long is it actually running and what does it translate in terms of infrastructure consumption or resource consumption. And then the month-on-month bill will be based on that. So it is pay-per-execution pricing model, which is extremely fine-grained than a typical VM that is charged on a month-on-month basis. So that is the second difference, pay-per-execution pricing model, which means even if you push your code and it is never executed, you are never going to be charged. You may have a very tiny piece of code, but that is invoked so many times and it is consuming a lot of resources, you might still see a significant cost attached to it. So that is pay-per-execution pricing model. The third attribute of serverless computing is it's completely transparent in terms of resource allocation and infrastructure provisioning. You will never have to pre-provision resources before you run your first line of code. So if someone is asking you to provision resources before you execute your code, then it is not serverless. So those are three attributes. So to summarize, serverless computing is all about event-driven programming model, pay-per-execution pricing model, and transparent resource allocation through infrastructure abstraction. So those are the three key attributes. Now coming to the technical benefits. Well, first thing, serverless computing is not a magic bullet. It's not a replacement of IaaS or PaaS or FaaS. It is not the next wave that is going to basically replace everything. Instead, it's a very, very good complementary execution model that enables certain use cases. So why should developers care about serverless and functions as a service? The very first thing is you are free to choose best of the breed tools. For example, you are developing a statistical application and you want to run it as a serverless snippet. You are free to choose Python, package that with NumPy, scikit-learn, or any of those scientific libraries, and you basically have a component in your portfolio that is highly customized to do statistical computing. So that is Python for you. Then let's say you are actually doing some message queuing and you want to do a store and forward processing. You are free to choose, let's say, Python or Ruby on Rails, anything that is ideal for that specific job. And similarly, when you're actually invoking a third-party API that comes back with a large JSON payload and you want to quickly parse that and push that to a data store, your Node.js is your friend. So you are free to choose Node.js as that code snippet responsible for invoking the third-party API, grabbing the JSON payload and pushing that into a database. So you're not confined, you're not restricted to one language, library, framework, or runtime. You can basically choose multiple languages that are best suited for the specific tiny function that you're writing. And over a period of time, you can actually combine all of them to form a very polyglot, very diverse, one application made of multiple diverse components. So that is best of breed languages, frameworks, and tools. The second thing is you have a lot of control in the way you deploy code, upgrade code, and manage code. Because your unit of deployment is one function, you can very easily manage your large complex application. So you want to upgrade one component, one service, one function. You can do that with very minimal downtime without ever impacting the rest of the pieces of your application. So creating that continuous delivery becomes a reality with serverless computing and function as a service, because you can define very fine-grained CI/CD pipelines that perform the build process and push the code into the serverless environment. So you can have a very well-defined CI/CD pipelines that will upgrade one component at a time with very minimal downtime. Third thing is lack of lock-in. Of course, serverless computing does have some kind of a lock-in, but end of the day, the code that you write is a snippet that can run anywhere. So serverless is considered to be less lock-in and less of an opaque black box when compared to other things like FaaS. FaaS has an extremely tight lock-in. The moment you push your code to a FaaS environment, it is very difficult for you to come back. That's why FaaS is like Hotel California. Whereas serverless, end of the day, you have your own code running there, which is very loosely defined. With very slight modifications, you can easily pull that code out of the serverless environment and run it elsewhere. So it is portable. And it is composable, right? And it follows the core principles of microservices that we have discussed earlier. So those are some of the benefits.
Excellent. Can you touch a little bit on some of the economic advantages as well, right? So from a business perspective, I mean, obviously you talked about the pay-per-execution pricing model. That can be really advantageous just from a cost standpoint, and obviously from a maximizing resource utilization, basically raw computation and the time for an execution to occur. Obviously, you want to optimize your code for that to make sure it's highly efficient. What are some of the other economic advantages that you see, in terms of deployment or flexibility, time to market? If you're building an application, is it a lot faster doing it this way? Maybe some other things that you could touch on in that area as well.
Right. So most of the enterprises are leveraging serverless for automating the operations and automating a lot of tasks. As I mentioned, it is not a replacement for existing service delivery models, but it's a nice complementary way of augmenting your PaaS and IaaS environment. So many customers are gradually moving to serverless, and they're running certain workloads that are ideal for that environment. For example, in some domains like manufacturing and supply chain, every time a new object is uploaded to object storage or a new entry is made to the database, automatically a serverless function gets triggered, it validates, it kicks off a workflow, and once the workflow is done, it automatically shuts down itself. So ultimately, it delivers better cost efficiency and also better management. And eventually, when microservices and nanoservices become mainstream, this is going to be the cheapest way of running the greenfield applications. So in a lot of ways, it is going to be the next wave of event-driven computing that can automate a variety of tasks. And when you combine this with some of the emerging trends in artificial intelligence and cognitive computing, it forms a nice conduit to invoking those intelligent services every time an event is triggered. So it's too early to talk about what is the overall cost of ownership and how much savings will an enterprise experience by moving to serverless or by adopting serverless, but these are some of the early advantages.
Okay, great. That's really helpful. So let me ask you a question about practically getting started. So, some people listening may know a bit about serverless or may have experimented or played around or even built applications or something involving service delivery in the enterprise, or they may work for an ISV that's experimenting with this and so forth. For people who haven't, though, and for people who might want to go deeper into it, how would you suggest that developers out there begin exploring, this serverless paradigm for real world applications? How do they get started? What kind of options are out there in terms of the vendors in the space? And maybe you could talk a little bit about which ones you particularly like or think that are strong from what you've seen and what you've experimented with, played with yourself.
Sure, definitely. So the shortest road to serverless is to pick the serverless environment of your favorite public cloud or the current public cloud. Interestingly, all the 4 top public cloud providers, including Amazon, Microsoft, Google, and IBM, have serverless offerings within their platforms. So if you're already familiar and have investments in any of these cloud platforms, you can easily extend your workloads to take advantage of serverless. For example, if you are familiar with AWS, then go to Lambda. If you are already on Azure, you can take advantage of Azure functions. And Bluemix has IBM Cloud Functions, and same thing with Google, which has Google Cloud Functions. But all of them are tied to one specific public cloud. But if you want to really learn the core concepts of serverless and you want to do it out of the public cloud within, let's say, your test environment or even in your laptop, my choice is Apache OpenWhisk. It is an open source serverless platform that was initially developed by IBM and Adobe and got donated to Apache. It is currently an incubation project. You can very easily get started with OpenWhisk on your machine. If you have VirtualBox and Vagrant installed, you can clone a GitHub repo and type Vagrant up. And in about 10-15 minutes, you'll have a very nice serverless environment configured on your local machine, and you can start tinkering with the whole experience. So that is the best way for developers to get started. But as I said, if they're already familiar with any of the public cloud platforms and they have use cases to extend to serverless, they can start with the native service offered by the respective cloud provider.
Excellent. Would you say, just a quick follow-up question I forgot to ask, would you say that these cloud providers out there, the maturity of the technology is pretty good at this point? I mean, is the documentation fairly good? Are there examples to get started? Is it pretty robust in that regard as well?
Yeah, every cloud provider has sufficient documentation, samples, tutorials, and jumpstart kits. But Lambda is one of the most mature because they have been around for a longer time and they have been rapidly expanding the serverless offerings. So if you are familiar with AWS, I think Lambda is one of the most mature offerings that you can leverage.
Okay, great. Another question related to learning and getting started with serverless and functions as a service as well. What resources would you recommend, whether that's online resources or books or anything else for people listening today to help them learn more about serverless computing? I mean, obviously they can go to Apache OpenWhisk or AWS Lambda or the other vendors and go directly and jump right in, but maybe they want more of a primer or tutorials or anything from very technical to maybe more high level. Could you make any suggestions there that people might look at?
Absolutely. The entry point to serverless computing is serverless.com. So you can't miss that. It is serverless.com. It's a very tiny company in San Francisco that is trying to democratize serverless computing and giving a common taxonomy and nomenclature to any serverless environment that you're targeting. So if you want to learn the absolute basics of serverless and learn a framework that can free you from any specific runtime or environment, you can start with serverless.com. They have a curated set of resources, and they also teach you how to write your hello world in serverless using the framework, and that is becoming a de facto standard. They support Lambda, Azure Functions, Google Cloud Functions, Apache OpenWhisk, and a couple of more vendors. So it should be your best bet, because learning serverless will open up the opportunities to target any of the popular environments.
Okay, good. That sounds like an excellent resource. Related to that, where can folks find any of your technology analysis? I mean, you do a lot of writing, right, about serverless and about other technologies, Internet of Things and so forth. Where can people find you online?
Yeah, so I'm at Janakiram M on Twitter. You can find me on Forbes Tech section, and most of my serverless articles and tutorials are available at thenewstack.com. So any of these resources will be useful for you, and I constantly write about the emerging trends in serverless. So those are some of the resources.
Okay, great. Well, excellent. I would like to thank everyone for joining the conversation today. I think it's been a terrific conversation, just introducing serverless computing, what it's all about. We hope that everyone learned something new about serverless computing. I would like to encourage everybody to check out Johnny's white paper on serverless computing. You can find that at info.dreamfactory.com/serverless_computing_WP. We'll be sending obviously a follow-up note with that link. info.dreamfactory.com/serverless_computing_WP. So go ahead and definitely check that white paper out. We talk about, or Johnny discusses a lot of what we've covered today. Provides some information about the technology vendors out there. We also talk a little bit about, or he mentions Dream Factory and our technology, and how that helps facilitate this idea of serverless, basically the ability to write functions, connect to databases really easily, get REST APIs that then you can code server-side scripting logic in a very lightweight and easy way. So that really helps bridge the gap, whether you're building, as Johnny says, a greenfield application, something brand new, or perhaps you're writing something that needs to connect to legacy data, but you want a modern way of implementing business logic that kind of provides a lot of that as a service instead of having to deal with a lot of provisioning and configuration and so forth. So check that out, and we thank everyone for joining today, and thank you, Johnny, for joining the conversation. We appreciate it. Thanks, everyone.
Thanks. I enjoyed the conversation. Thank you.